Good morning and welcome again. This time we're going to talk about the current LCA analysis that we're doing with respect to ethanol. And I want to touch on something that some things that have been going on with the write-up that you have. First of all, let me just say that on the background piece, what I'd like you to do is broaden the scope a little bit. You need to look at literature on nutrient flows, on energy flows, and this debate about gasoline versus ethanol, particularly as it relates to carbon dioxide emissions. There's a lot of controversy still after years of analyzing this ethanol on whether the ethanol process produces more energy than it uses or uses more energy than it produces, and whether the value of output of the ethanol is greater or less than the value of the input that was used to produce the ethanol. So again, there is a debate still about whether we produce more carbon dioxide or less carbon dioxide, depending on whether we use gasoline or ethanol. Also, I noticed be careful about the numbers that you post. Even myself, I have a continuing problem with this. The current legislation, the current Energy Act, mandates X number of gallons be produced by a certain year. And my understanding was that as I reflect on that, and I'm not quite sure, even though I've written about it, I think it's like 12 or 13 billion gallons that is required now to be produced of gasoline, and that is why, of ethanol for gasoline, and that's why we're producing the amount of ethanol. It's a mandated requirement by Congress that this much ethanol be produced. So it doesn't matter about any subsidies or whatnot. If the government mandates that the blenders use that much ethanol in the gasoline, in their gasoline distribution, then that's what they're going to use. And so that's what's driving the ethanol market. Remember that there's 3.83 liters per gallon, so you can't have more gallons than you have liters. In other words, in one statement it says in 2006, 18 billion liters, or approximately 48 billion gallons. Well, that would be kind of reverse. Go back and make sure that those are correct. Again, you might want to go to the Energy Act that created that. I've written a number of articles on it. I know there's a whole bunch of literature on the Energy Act that talks about how much energy from ethanol is required and how much energy from ethanol that's made from cellulosic sources is required. And so that's another important point. The requirement is, I think, by 2020 that a certain percent of that, or a certain number of gallons, be from cellulosic ethanol and not just from corn ethanol. So let me move on from that. In your analysis, and I think you've got some good things in here that you're going to look at with respect to the LCA itself. I do want to talk just a minute about how to lay that out and what I was kind of looking for, if I can find my chart here. I hope you can see this. I normally would do this on a blackboard, but I want you to understand that we're looking at ethanol, and ethanol comes from corn. We're just going to focus only on corn to ethanol in this example. And then remember that there are inputs, as you've noted, that produce corn. But what I don't want you to minimize or forget about, in this case this would be from the cradle, is that there are lots of inputs, and there are inputs that are needed to create those inputs. And so in a material flow or an energy flow, you have to go all the way back to that main source of that material that was used to create the ore, that created the steel, that created the tractor, that created the corn. And so you'll have to do that, and then remember that from corn to ethanol, there is a whole set of machinery that had to be made that used steel, that used aluminum, that came from some manufacturing plant. That manufacturing plant also had to be created by something. So you get my point that it's a very difficult process to go all the way back to that mining of that ore, and the machinery and equipment and fuel and whatnot, labor that it took to get that ore out of the ground, shipped, put into the factory, and then finally producing that ethanol. And so the final product in this case is ethanol. And so we've gone from cradle to gate here, being we've gone from the ores right to the product that is being marketed. And so in this case, all we've gone to is to the gate. We have not gone from cradle to grave or from cradle to cradle. That would be a whole other step to go beyond ethanol and figure out what happened to that ethanol after it's been used. So please work on that. Try to look at that. Try to think about that process. And there are articles out there. As I've said, there is research out there that has actually measured these things and done the LCA and it's interesting because some of them say that the process uses more energy than it produces. Others say that's not true. It produces more energy than it uses. Some of the ones that say that it uses more energy than it produces say that the value of the energy that's produced exceeds the value of the energy that it used. And so there's a whole spectrum of analysis out there, and I suspect when you look at it, you'll see, as I've done it, that a lot of what the output is depends upon what the assumptions are with respect to the industries and how they've modeled that LCA from what point the resources came, whether it was from a cradle to gate, or whether it was from cradle to cradle, whether it was from gate to gate. So anyway, you're doing good so far. Keep on that. Try to put that. Try to build that model together, and then we'll work on that. Once we get the ethanol one done, we'll try to work on the biodiesel. All right. See you next week.